Yeah, I have somebody who's waiting. So when we take all that we learned, all those 4 different angle types, and we place them onto 2 parallel lines cut by a transversal, these are postulates or theorems that are true. So same side interior angles like these, 4 and 6, we would say they add up to 180. They are supplementary. And then if we move on to alternate interior angles, said if we have 2 lines that are parallel, cut by a transversal, then the alternate interior angles are actually congruent. So we're going to prove that. So we start with the fact that these 2 lines, A and B, are parallel. And then we're going to go ahead and prove that angle 2 is congruent to angle 3, and angle 2 and 3 are in the position of the alternate interior angles that we just talked about. Okay, so if we can prove 2 is congruent to 3, we're proving that alternate interior angles in general are congruent if the lines are parallel. Okay. So we start with the given if the lines are parallel. So write that down. So write down A parallel to B. This, by the way, is the symbol for parallel, and that is given. A is parallel to B, that's given. And then we're going to say that measure of angle 1 plus measure of angle 2 equals 180. Why is that in this picture? What kind of angles are 1 and 2? This goes back to last chapter. Angles 1 and angles 2. We got angle 1. Angle 1 is this guy. Angle 1 is the one below it. Angle 1 is this guy right here. And angle 2 is this guy right here. Those 2 angles together make They do make a pair. They make a 180-degree pair. We call that a linear pair. Okay, so those 2 together make a linear pair, and that's the reason. They are a linear pair. So 1 and 2 are a linear pair. Now, we just learned this one, so it might not be right on the, you might have already forgotten what we said about this, but angles 1 and 3, what kind of angles are they? Awesome. And what's true about same side interior angles in the postulate just above this? They have 180. So we would call this the same side interior angle postulate. So same side interior angles. And you can use the symbol for angles. And we're assuming that we're talking about the postulate that is about same side interior angles. So that's it. So measure angle 1 plus measure angle 3 equals 180 for that reason. When you see 2 things equal to the same thing, what do we do with them in the next state? Typically. Yeah, set them equal to each other. That's kind of the pattern of these proofs of all 3 of the ones we're going to do right now. And the ones you're going to do for practice. So yeah, so we have measure of angle 1 plus measure of angle 2 equals measure of angle 1 plus measure of angle 3. So you set them equal. That's the transitive property we call it. And then you got to write down both the statement and reason here. Hopefully there's enough room there. And when you have 2 things equal and you want, so you have this, all this stuff on the left equal all this stuff on the right, I really wanted to just say 2 is equal to 3. Is there something that's common on each side? So if there is, we're going to subtract that out. Yeah, so angle 1 is common on each side, so we're just going to say measure of angle 2 equals measure of angle 3. That's by subtraction property. We subtract out measure of angle 1. Then the final step is just to say angle 2 is congruent to angle 3 because when their measures are equal, they are the same size or congruent. So that's the proof. you're going to end up doing one like that in the assignment as well. And use this as your guide. Right, so the first one was a postulate about same-sided interior angles being supplementary. This one is about alternate interior angles being congruent if the lines are parallel. The next one is proving that corresponding angles are congruent if the lines are parallel cut by a transversal. So here's how this goes. We start the same way. Every one of the proofs in this section, 3.2, start with the lines being parallel. If the lines are parallel, then this is what must be congruent or supplementary. And then in the next section, we're going to do the converse of each of these. So we'll start with if 2 is congruent to 6, or if corresponding angles are congruent, then we'll be proving the lines are parallel. So it works both ways. We call that a true biconditional. It's a biconditional, but it's actually true. It works both ways. We've written some biconditionals that aren't necessarily true. So A is parallel to B is given. Measure of angle 2 plus measure of angle 3 equals 180. What do you think? Linear. Okay, there we go. Okay. Give you a chance to write that down. So A is parallel to B. This little symbol for parallel, usually we do it like this. This is our best that we have for that. That's the symbol for parallel given. Measure of angle 2 plus measure of angle 3 equals 180 is linear pair. 3 plus 6 equals 180. What's that? Same side interior again, yeah. And two things equal to the same thing, what do we do with them? Yeah, set them equal to each other so you kind of know the format of the rest of this proof here. So we have measure of angle 2 plus measure of angle 3 equals measure of angle 3 plus measure of angle 6. Into the property. And then subtract out the measure of angle 3 from each side. When you do that, you have measure of angle 2, measure of angle 6, and then angle 2 is congruent to angle 6. Pretty similar to the previous one. I wouldn't be surprised if one of these doesn't show up on the test, and you have to fill in the blanks. So we'll give you part of it. Maybe I'll ask you to do one of these from start to finish. Maybe at least the picture and trying to prove one. Oh, I forgot to hand these out. All right, and then the last one here, we're going to prove that alternate exterior angles are congruent if the lines are parallel. So A parallel to B is given. 1 is congruent to 5. You know why we can say 1 is congruent to 5? You have to ask the question, what kind of angles are 1 and 5? They are, but like what type are they? They are congruent. What type are they? Because that's what makes them congruent. Combined with the fact that these are parallel lines. So if lines are parallel, what kind of angles are congruent here? If lines are parallel, what What kind of angles are 1 and 5? We have 4 choices. Same side interior, alternate exterior, or corresponding. Yes. So if lines are parallel, corresponding angles are congruent. And number 3, this goes back to last chapter. Angle 5 is congruent to angle 7. Why is that? Vertical angles, yeah. And then number 4, hey, we just had 2 statements where they're equal to the same thing. What's going to follow? 1 is congruent to 7. We've got 1 is equal to 5, 5 is equal to 7, so angle 1 is congruent. Angle 7 by transitive. So those are the 3 theorems for congruence, and then the 1 postulate for supplementary. And you're going to be asked to do, I always like these. I remember these from high school, but these little find the measure of the angle based on what type of angle it is. It looks like this. So you'll have some of these to do today. Like if measure angle 5 is 65, can you use that to find every other angle that's numbered on this picture? Think so? So if that's 65, what's the one vertical to it? 65. And what's the one next to it? 115. How do you know it's 115? Yeah, 180 minus 65, in case you're wondering. What about angle 8? You can remember angle 8. 65 because it's corresponding or alternate exterior, your choice. But 65, and then what about 9? 15. So it's like, if these are parallel, here's the parallel markings. You gotta look for those first. I should have said that first. If those lines are parallel, you can basically take this vertex right here, slide it over here, and place it over the top. So they'll all match up. So if you picture it in that fashion, that's how these theories work. Just to suggest, let's see if we can match these up. A and C. What kind of angles are A and C? You guys don't have this in your notes. I'm just checking. Just a quick check there. A and C they are cute in this picture, but what of the 4 angle types are they? Corresponding. And if these are parallel lines, what's true about corresponding? That didn't work. So let's check it. Corresponding. What about F and E? You say anything about F and E? Alternate interior, yeah. Anybody want to try this? Drag and drop? Oh, no, I really messed it up. So that's going to mess it up. But you get the idea. I completely messed it up. Let's see if I can move it down back. Maybe. Yeah, okay, they're lined up again. We're set. But B and D, what are B and D? Are they anything? They are same side. They're same side exterior. Do they have any theorems or postulates that tell us what the measures of same side exterior are? They're definitely not congruent. Look at B and D. They don't look like they could even be congruent. Could they be supplementary? Well, maybe, but we don't have a theorem about it. So they're definitely not equal. False in there. G supplementary to E. That's because they are same side interior. And H equal to E. That's because they're vertical. And then B and A equal 180. Yeah, that's because they're a linear pair. And then D congruent to F. That's not true. They don't fit into any of our 4 angle types that we can. That's it.